right? So, okay, good. So as usual, okay, the schedule for this week, almost last week of the course, right? So we are here, okay. So we finished discussing the authentication with an example, how to implement it in practice. It will take a little bit of time because there are many modifications we need to do to the application, both on the server and the client side. The server is already prepared, so we only have a look at the server, and then we will have a look at the client where there are more things to discuss, let's say. The server is almost, checking, copy pasting and then do some checks, okay, in the APIs. Okay, so tomorrow there will be the lab, which is still about the complete client-server interaction. So you finish the operations, the CRUD operations toward the server. So the create, update, and I think you still have to implement the delete as well. Okay, and then we will finish on Thursday. Hopefully, we will finish. Okay. Discussing for sure multi-factor authentication with the example, and with this last set of slides, just a few final considerations about security in general. Okay, if we don't finish, we will finish on Monday, not the week after, because it's empty because of me actually going to a computer conference, and so. But I will confirm to you this, of course, after Thursday. And then we still have 2 labs, one dedicated to authentication, of course, and the other to second-factor authentication. They are important because these topics are included in the exam, okay? So you need to master them. And then at the end of that week, there will be the text of the final exam, the first exam, sorry, not final, first exam published, okay? First, it means that you have 2 possibilities at the end of the course, one in June and one in July. Okay, and then last lecture I left it at the end of the course, so we also have the possibility to talk about anything, okay, in that last lecture, and just an example. I will publish the text before. I think I can do this week or even before, and then you can try to solve it just for practicing and see what are the differences, and we can have a discussion here, and then I will publish a possible solution, okay? Okay, so that's the schedule. Unless you have any questions, I think we can continue the discussion that we started last time. And last time we were talking about how to implement the authentication with username and password, okay? And this is the basic login flow. You insert a username and password. It's a form, a React form. You already know how to implement a React form. Just need to make sure you just answer with generic response to client, but this is from the server side, okay? And then if username and password are correct, the server generates a session ID, and the session ID is sent back from the server to the client as a cookie, okay? HTTP only cookie, so JavaScript cannot read it. The cookie is completely managed by the browser, okay? So we saw the React form, nothing special, just username, password, and of course you can do some logic, just to prevent submitting a form with empty fields and these kind of things, okay? But the rest is pretty basic. Right? And then on the server side, we say that we use a library, a package actually, an npm package, which is called Passport, quite flexible and modular, and we were looking at how to use it. With the local strategy, that is the one that allows us to use the credentials, username and password. And we need to modify a few things. We will see them during this lecture. So a callback, okay, we will use it, we will implement it as it fits for our application, but we will come back to these points when it's needed, okay? We were talking about how to store passwords on the server. You remember I left this thought to you, okay? And we say never store clear text passwords on the server. It means in the database, okay, because that's a permanent storage for the server. Any kind of database, not just our SQLite 3, any kind of database you might have. But just store hashes computed from the password. So the first time the user sets a password or the administrator sets a password for the user, it just computes the hash and then it stores the hash and it doesn't store the actual password. There are a few reasons for that, right? Because in this way, nobody can know the password just by reading the database, the list of entries in the database, because you only see the hash, and the hash is not an encryption function. It's a one-way function. It means that once you have the hash, the value, you cannot go back to the original value, okay? If it's a secure hash function, okay? So well tested, I would say. Okay, but the point is that you can guess passwords, right? So that's one of the biggest issues we have currently. I mean, in general, in application that requires credentials. And if the user uses weak passwords or too short passwords and so on, they can be guessed, okay? There are many users which are lazy and sets very common passwords or very common combinations of strings and so on to create passwords, right? And so one additional thing is useful to do in terms of security of storing password on the server is to use what we call the salt, okay? The password salt, so it's a unique randomly generated string added to each password before the hashing process, okay? So it's concatenated. It's basically the password is a string, this hash is another string. The mechanism puts the strings together and hashes the password. Hashes the string and gets the hashed password, okay? So always use salt when hashing password, but that's easy also for the exam because we don't want you to invent anything. Try not to invent anything in security because there's a very good chance you do something wrong, okay? So rely on well-established standard practices and so on, okay? This is really well-established standard, okay? Also because, I mean, it doesn't give you additional complexity because adding salt does not increase the complexity of the hashing process. It's just hashing a different string, right? So concatenating a string is very easy. But it has a very positive effect in case something wrong happens, like the list of hashes is leaked to somebody who shouldn't get it, okay, to some attackers and so on. And this happens so often. I mean, unfortunately, so often. You can read the news about security, about hacking, cracking, and so on. This happened to big websites as well, okay? Like, I mean, sites with billions of users, like LinkedIn was a famous case a few years ago, and I think Yahoo as well, and sites as big as this, okay? So, if you just have hashes without the salt, the problem is that the same password maps to the same hash, okay? And so this hash, I mean, if you see two hashes which are the same, actually the problem is that you recognize that the two passwords should be the same. And typically passwords which are the same are also the weakest ones. So you are giving a lot of information to attackers in case you don't use the hash. Instead, if you use the hash, and in particular you use a different hash for each single user, you force anyone who tries to do brute forcing attacks, so encrypting a lot of common passwords, sorry, not encrypting, hashing a lot of common passwords to see if they match the hash, they must do it for each single user every time. So instead of doing once and comparing to a billion of entries, it must be done a billion times to compare it to a billion entries because the salt is different for each entry. Okay? This is very important. Of course, this example is very simple. So the hash is short, the salt is short. So it's, you know, everything is bold to fit in the slide. But the principle is this one. Okay? It's really, really important. Okay? Okay, how do we implement this mechanism? I hope I convinced you the last time and today that it's necessary, but now we need to find an implementation, a good way of implementing this hashing system. Well, what we recommend, I would say we also require for the exam just for practical purposes, because if everybody comes at the exam with a different idea how to perform the hash, we need to search, if the idea is correct and so on. And in general, that's not a good practice anyway, as I told you. Try not to invent anything, particular in security. Just rely on well-established standards, okay? And what we recommend here is using this function, password hashing function, which is named script. It generates the hashes in the form of a string, which is very convenient because, database it's easy to store strings in a database. We also have online tools and other stuff, which is very convenient, to do testing, stuff like this. Password, okay. Script, but if you put a different salt, you see that every time the salt changes, the hash change, okay? This is just a tool, just for convenience, but in practice, you wouldn't rely on web-based tools to generate the hashes, right? You do it in your code because you tested the code and so on. And the nice thing is that in Node, it is already available in the already included crypto module. So you just do import crypto without installing anything. There are packages that comes with Node by default. Okay, so you don't have to do npm install this time. And it's already there. And you just import it and use it. And the salt is up to you. You need to manage it by yourself. Okay? So it's a different entry in the database, different from the hash, okay? At least in principle, okay? And then there can be functions or systems or libraries that handle everything together. So basically you give a password and a salt and they give you a string to store that includes also the salt. But that's not the case, I think, for this function, okay? So crypto has two functions, script, takes the password and the salt, and it gives you back, I think it gives you back, it returns a promise, okay, just, not to block the execution of your program. In general, when a function is supposed to be complex or time-consuming, it should always return a promise, okay? I think it returns a promise that solves to the hash value, okay? We can see it in the code later. I don't remember at the moment, sorry. We want to have a certain length of the hash, okay? We specify a length, that's fine. Any value is fine for this course. We're not focusing on this too much, but in general, 32 characters are enough. Salt, the salt is decided by you. Just use some reasonably random value and put it in the database or in these functions, and in case you really need to create it through the code, you can use this function. But actually, typically at the exam, we don't ask the part of creating new users, okay? Users are already stored in the database just for convenience, and because also there's nothing really special in creating new users, and so just copy pasting code, so we don't really care that much. And then the second function you really need for making all this system work is checking if the two hashes match, okay? And actually you could in principle do a comparison with equal, triple equal, and so on. But as you see, it's better to use a function specifically designed for this purpose, okay? For instance, you see the name timing safe equal, okay? Just to make sure that given the time it takes to make the comparison, you don't leak any kind of information to the attacker, okay? The given password must be hashed with the same salt of the stored password, of course. So you need to pass, the stored hash, so it must, stored hash, yes, and hash password, okay? So what is stored in the database and what comes from the function, okay, that does the encryption to check if the two matches, okay? So that's how to use it. I mean, and this is mostly copy pasting. I mean, we just have a look at this code and use it, okay? And that's on the server side. That's why I was saying that, I mean, the server side, there's I mean, there's not so many things we need to check or write on the server side. So, or export, that was the old syntax with the CommonJS model, but it doesn't matter. I mean, it's a function get user, email password. I mean, email that is supposed to be the username, okay? In this example, I should write username, maybe it's clearer. Anyway, many times the username is the email, so it's fine. Email password, and you need to go to the database and search for the user. If there is a user, so there is no problem in searching in the database, and there is a row in the database that corresponds to the email that in this case is the username. The user, you retrieve the user, so ID, email, and so on, but also you retrieve the salt, okay, that is in clear text in the database, and then you compare it with the hash, okay? So you hash the password that comes in as a function, because when you do the post for the login, you are sending the password to the server, okay? And so you take the password, you do the hashing, password here, you do the hashing, and you get back the hashed password, okay? It gives it back in terms of a callback, I think, yes. So why I say a promise, I think there's something wrong here, sorry. No, it doesn't return a promise, I mean, it calls a callback, okay? Sorry for that. I mean, it's 3 years we are doing this course and we didn't catch it, sorry. So there's a callback called, like with the SQL3 module. When it finished the execution, like here, arrow, and that's the callback that is called. And then here, I mean, we want to return a promise. So in case there is any error, of course, we reject. Otherwise, we do the comparison. If everything is fine, we resolve, okay, with the user, okay? That's a possibility, okay? Otherwise, resolve false, that's another possibility. I mean, we need to indicate the fact that the password doesn't match or it matches. False or user, I think user is an object, okay? Can be simply tested with if, right? If it's false, the if evaluates to false. If it's an object, it evaluates to true, okay? So that's why we use this convention. But that's just a sample implementation, okay? Just to give you an idea what we should do, okay? Okay, good. So we tested the password. At this point, we need to establish a session. Remember what a session is. We need to establish a session ID and send it back to the client with a cookie, okay? Again, we are not implementing anything by hand. We use an additional middleware that enables sessions in Express. By default, Express has no sessions, okay? So it's just a web server. So there is a convenient package named Express Session. You need to install it, this one. By default, it stores the sessions, its memory. We know it's not that efficient, not recommended for production purposes, but it's okay for the exam, okay? We want to do simple things at the exam because we want to check the code you write and if you understood the concept and so on. So the purpose is not having a production-ready server and client, okay? So even though we say highly inefficient and so on, it's okay for the exam. Why it's highly inefficient? I would say inconvenient, because you know, if you restart the server, you lose all the session IDs. Okay, so if you are just testing at the exam, that's fine. If you have 1 million users, you're logging out 1 million users at the same time. Users are using your website, they see I'm logged out, they want to log in again at the same time. It becomes a problem for your website, right? Just as an example. It also supports differentiation strategies, files, database, and so on, but we are not going to use them. Okay, in case you really want to use actually Node.js for your server and you want to scale and so on, I think you need to think a little bit more about this decision. But if you really want to go this direction, maybe you have a lot of other things to care about before this. Anyway, session content. We need to decide what to put in the session. Okay, so basically the session creates an ID, and this ID is stored in the session memory on the server. But then you might want to associate some information to the session ID, and for sure there is one piece of information which is required. Okay, you cannot do anything without it. So you logged in a user, you need to have an identifier for the user to associate the session ID with the user. Okay, typically the user ID can be the ID in the database, can be the email, any unique ID of the user is fine. Okay, because you want to know that this session belongs to a certain authenticated user, and this user is some user that corresponds to a given ID. Okay, so how do we attach information to the session? Okay, there are two methods that we need to implement. I mean, actually, we need to pass callbacks to these two methods, serialize and deserialize user. They are called user just because typically you associate user information to sessions, right? But you can associate whatever you want. You see, this object is what you keep on the server together with the session ID. ID, user ID, email, user, first name, and so on. You can put whatever you want here, okay? Typically, you don't put that much information, because once you have the ID of the user, you can retrieve all the rest of the information from the database in the server, okay? And this serialized user, actually here, I mean, you just want to retrieve the user object, that's fine. Okay, so there's nothing that you really need to do in particular except taking the object and pass it to who is using the object. How do you use this object? Well, it will be automatically associated to the request, okay, the web request, in the user field or attribute of the rec object, okay? If a session is active. So everything happens automatically. Once we say we want to use password, we want to use express sessions, everything will happen automatically, okay? So if the request comes with a cookie, this passport plus the express session comes in, and they look at the ID of the session, look if the session is valid in the memory, in the list of the valid sessions, go take the information from the user and give it back to you in your code as rec.user, okay? Everything happens automatically. And if there is no session, this rec user, as usual in JavaScript, will be set to undefined, okay? It's a field that doesn't exist in the rec object, okay? Good. So minimal content in a session, I told you, a unique user ID. That's a minimal content, okay? Because, I mean, if the session is not associated to a user, it's basically useless, right? And then during the serialization, you can also retrieve additional information if you really want and so on. But, I mean, it's really up to you. I think we will give you some sample code. You can just use it as it is. That's fine. If you think it's good to modify it, that's good. But keep in mind the fact that this code will be executed every time you see a request on the web server that comes in with a cookie. Okay? If the cookie corresponds to a valid session ID, the express session will execute this code. So try not to put too heavy operations here, I mean in general, as a principle. Okay? Then depending on the request, you might want to retrieve information from the database, but that's for later. Okay? This is done every time you see a cookie, even though the request doesn't ask you to do anything on the server. Okay? Because it's triggered by the fact there is a valid cookie that represents a valid session ID. Okay? Good. So, in short, we are done here. Okay? So, passport plus express session, and it's just copy-pasting this code. Login, we need a route for login on the server. Okay? It's a post, as we saw last time. API session, that's a recommended name, but again, up to you. API login, still fine. I mean, something reasonable. And you need to call this passport authenticate local. That is a middleware provided by password that performs this authentication. And so it goes and calls this function that we saw before, this verify, and so on. Okay. But I mean, I think we can see it in implemented code. It's much easier. Okay. And then what do you return from the login API? Well, again, it's up to you. Typically, login API returns some information about the user. Okay, you log in with the username and password, and they give you back, let's say, first name, last name, and I don't know, last login time, whatever you think is appropriate. So they can write you, hello, Enrico, welcome back, and so on. Okay, that's a possible use of the of this API. Okay? Otherwise, you need a separate API if you want to fetch information about the user. But since you already made a request, it was successful, why can't you send back some information about the user? Indeed, that's a typical case. Okay? Good. Then we get back the information from the user, and we are back in React in the client side, right? Where do we store it? As any other information coming from the server. We store it in a React state, okay? So we will create a state that that stores this information coming from this API, okay? Typically, that's a state that contains an object, the user object with an ID, email, first name, last name, whatever we think, again, it's appropriate, okay? It might be stored even in a state that is exposed to the rest of the application as a context, okay? Because it's something that is typically useful in many places in the application. But again, context is not mandatory. So, I mean, if you think it's good for you, it simplifies the implementation and so on, you can use it. Otherwise, you simply pass props around in the components as we did until now, okay? Okay. Often we also have an API on the server side and on the corresponding code on the client side that can ask user information in general. Why we need this API? Yes. We need this API because we don't know if we are authenticated or not on the client side. Remember, we cannot read the cookie. We cannot just check, is there a cookie for the website, I don't know, mywebsite.com and so on. It's HTTP only. We cannot know it. Even if it's our cookie, our application, our JavaScript code and so on. Just for security purposes, as I told you, okay? So nobody, including us, can access to this cookie. And so the only way we have to understand if the user is currently logged in, so it means the client has the cookie that corresponds to an active session ID on the server, is to send a request to the server, okay? So we need an API on the server that can answer, typically with the same information that you get back from this API session or API login route on the server. And if there is a session, it says, okay, that's the information. If the session is not there, it will say, well, access denied or whatever, okay? You don't have to show it to the user, okay? Especially if you do it at application loading time. So when you open the application, as we will do at the end of this lecture, I mean, simply the user didn't log in yet, or the cookie we have is for a session that already expired, okay? Sessions might expire for many reasons, because they have an expiration date. In our case, that's because we restart the server, okay? Because they don't have an expiration date. Again, in our simple server, just for convenience, they are stored in memory, and it means when you restart the server, the memory is lost, okay? Okay, good. Here you find a link for more suggestions and so on, but I mean, the basic things will be on the slides. And then after the login, well, you logged in because you wanted to protect some information on the server. So it means that it should be some APIs that do the check. Does the request comes with an authenticated session or not? And that's one thing we need to implement. And luckily it's easy, okay? So some routes, some APIs on the server must provide a response only for authenticated users, okay? And potentially, I would say typically, depending on the user, they provide a different response, okay? Because it's like the shopping cart list. I mean, myself, Enrico, has a certain list. Another student has another list, and so on, okay? So depending on who makes the request, so the session ID that is sent together with the request, the answer will be different, okay? And potentially also saying, there's no session ID, so you're not authenticated, I have nothing to say to you, okay? Not authenticated, that's all, okay? Okay. Remember that the browser automatically sends the HTTP cookie header to any API belonging to the same domain and path, okay? But this is not a problem because we set the cookie from the API server. So in our case, localhost 3001, and we send it back to the same host name plus path, okay? Localhost and slash, okay? The port doesn't count. But I mean, that's just our simple setup on localhost. It can be api.bank.com and www.bank.com, okay? Two different hosts. Okay, so you remember that we had the course problem. Now we need to make a little bit of a little adjustment to this configuration. I already told you, but now I remind it to you. We need to include this option, credential true, okay? Because by default, the browser will not send requests, cross-origin requests with the cookies, okay? Again, for security purposes, unless it's instructed to do so, okay? And so we need to configure the course on the server to send headers saying, okay, please, it's okay to send cookies as well, so session cookies and so on, okay? That's the name of this option in the course option on the course package on the server, okay? If you set credentials true, you are not allowed to write origin star, okay? It would be a nonsense, right? Because it says anybody can make requests and sending me cookies. I mean, cookies are just needs to come only from a specific set of host names, okay? The ones that are designed to work with my server, okay? Okay, that's on the server, but on the client, the fetch doesn't send the cookies by default as well. So you need to tell the fetch to send the credentials, it means the cookies as well, together with the request. Even if it's a get, or post, put, and delete. For post, put, and delete, you need this object that says method, post, put, delete, and so on. But also for the get now, because if you need to perform an authenticated request, you need to write credentials include, okay? And the login request must include such option as well, because, I mean, it's a limitation of how the library in the browser has been implemented, okay? The fetch has been implemented, okay? Just be aware of this, okay? Just add credentials include when you do the request also for the authentication. So the API session or API login that we saw before. So now we need to protect the APIs on the server. There is a function provided by Passport, is authenticated, that is available on the request object, okay? So it returns true if the session ID coming from a request that is valid, so it's currently in the list of the valid session IDs in the memory of the server, or simply false in other cases, okay? And this is to be called at the beginning of every callback body in each API that needs a protection. So you remember that we write api.post/ and so on and so on, add answer, and then we have a callback. At the beginning of the callback, make sure you check if the request is authenticated or not, okay? Since it's to be done in different APIs, in many APIs, it's good to create a custom middleware. So, this is quite simple. I mean, it's just an if. But then, if if it's not authenticated, you want to give an answer saying not authenticated and so on. And you have to copy pasting this in all APIs on the server if you don't have a middleware that encapsulates this behavior in a single place. Okay? So that's one possibility, but I mean, I encourage you to use this middleware, which is very simple to write. Okay? Just copy pasting again. We call it is logged in, rec res next. That's the way in which we write a middleware for Express. So request response object and next, which is a function to be called at the end to prosecute with the rest of the functions that handles the request. If rec is authenticated, return next. That's fine. Otherwise, return res status 400 and not authenticated. 400, I don't remember what is 400, HTTP 400 status. Let's see, bad request, okay? But I think there is also 401 if you like it more, okay? Unauthenticated, that's fine, okay? In any case, it's a series of codes which is not good. I mean, it's not 200, so it will not be response okay and so on. Okay, how do you use it? Very simple. You put it in the list of elements you pass to the, this function get post put delete here on up when you define the route on the server. Okay, so before the callback, just insert is logged in, and Express will take care of calling this is logged in function, this middleware, checking if the request is authenticated or not. If it's authenticated, it goes to the next one. It means your function and so on. Otherwise, it returns with this message. In this way, this message is the same for all the requests, okay? That needs to be authenticated in case the request that comes from the client is not authenticated. Okay, so you write this code only once, okay? Instead of copy pasting in all the places where you need it, which is never good, right, in programming. Okay, but remember that authorization checks are very, very important, okay? I gave an example a few weeks ago, I think. Yes, it was just, you know, big security bug, but I mean, this is just an example. I mean, next year maybe I'll change it if something else happens. Okay? So, API implementation must always check if the user has permission to do the operation. This is one of the things that you know, many students get wrong at the exam. Okay, so please pay a lot of attention to this, and we will pay a lot of attention during the example the last day of the course, okay, to these things. You need to check if, not only if there is an active authenticated session, okay, but if the authenticated session corresponds to a user that has the permission to perform the operation that has been requested. It's not enough that I'm authenticated, okay? I want to, I don't know, delete an item from a cart, okay? I give you the item ID, okay? It's not enough to check the request is authenticated, because anybody who is authenticated means any user in your system, in your application, who is currently authenticated can do this request and pass the authentication check. You also need to make sure that the user has the right to do the operation. So in this example, I told you that the ID refers to an item that belongs to him or her, okay? It's his card, her card, and so on, okay? Otherwise, we delete an item from a card of anybody. We don't know which one. Okay, because we don't do the check, and a malicious user can send any ID, and if it's a valid ID, of course, so it corresponds to some items, it will be deleted if we don't do the check. Okay, and this happens. This example is exactly about this. This is called insecure direct object references. Okay, I pass an ID in the request saying, please delete item 1234. Nobody checks if the item 1234 belongs to the user that is currently authenticated, and you delete the item 1234, and that's a problem. Or you access the information. I think this was just accessing information. So you expose information that shouldn't be exposed, because it's not information for you. give me the amount of money on the account number 1234 in the bank, okay? You should check that the currently authenticated user is the owner of the account before giving back the information to the user, right? You cannot just trust the fact that it comes from an authenticated session or somebody else did the check on the client. I mean, the thing that makes me sort of mad at the exam is when students say, I did the check on the client. Of course you did it, but I mean, the attacker didn't do it, right? The attacker just threw in a number and hopes to get something back, okay? If you don't do the check on the server, that's a problem, okay? And you see, it happens also on big websites. Okay, so please make sure you do all these checks, and we will look for these checks at the exam for sure. And we always do, we always did it, okay? Because this is a cybersecurity course of study. Even more in this course of study, we will do these checks, okay? Also, it's not enough to do checks, you know, on the basis, I just said, I mean, okay, it belongs to the user. I must retrieve the user information in a secure manner. The only secure manner on the server side is to access the rec user object, okay? Because rec user is set by the server. I cannot trust you if you say, I'm user 123 and I want to delete item 456. I mean, I cannot trust the fact that you're user 123. I can only trust the fact that on the server there is a session active that is the one that comes with this request, and it associated this session to the user 123. At that point, I'm sure that is user 123 who authenticated before with username, password, whatever, and that session ID corresponds to that user, and so I can do the operation and delete item 456 because it belongs to user 123. Okay? Again, this is really important. By the way, this means that it should be no information about the user coming from the client. It's a design error. Every time I see this stuff, I'm sure that, I mean, almost sure that you did something wrong in the server, because there's no reason to pass the information about which user is doing the request. It's connected to the session ID. And if you retrieve it in a different way than the session ID, it's wrong on the server side, okay, from the point of view of security. Okay, I hope you got the idea, right? But I mean, really, so many people lose so many points on these items at the exam. So please don't be the one who loses the point. Okay, so only rely on trusted information on the server side means it should come from the session or it should come from the database. If it's in the database, hopefully it has already been validated in some other places before being put in the database. Okay, like the owner of the item, you should check if the owner is the, you should check which is the owner of the item, looking at what's stored inside the database, not what comes from the client. That is insecure by default, okay? As for who is the user associated with the session. Of course, saying this in this way, it's easy, right? Who is the user associated with the session? But I cannot just keep the take the information coming from the client to understand who is the user making the request. I need to look inside the association between the session ID and the user. Okay? Okay, example, again, the delete reservations. Okay? I want to delete reservation 1234. Of course, is logged in. I mean, I want to have an authenticated user because I need to check if the user owns the reservation before doing the operation. So no unauthenticated user can have this functionality. I cannot accept delete request if there is no authenticated user. Okay, that's sort of obvious, right? Because I don't know if the owner is making the request or not, right? If there is an authenticated request making the request, I mean, if there is a cookie coming from the client to the server, there is a corresponding session ID. This session ID corresponds to a certain user. At this point, I can check if the reservation was done by the user, okay, that is actually associated to the current session. So you see the rec user has been set by passport and express session, okay? So this is secure. So if ID is written here, and it's for sure the ID of the user who authenticated in the session before. Good. And when you delete, when you perform the operation, you need first to check if there's a reservation ID that you got from the client, and you need to get it from the client because maybe the user has 5 reservations. So you need to know which one the user wants to delete, right? But before doing the operation, you need to check if the owner is actually the same that is associated with the session, okay? So again, many students take this wrong. I mean, I would say that insisting again and again in last years has reduced this number of students, but I mean, it's really important to understand this point, okay? Especially in the cybersecurity course of study. If you don't do this kind of checks, you have these problems. And at a certain point, somebody will discover there are no checks on the server and will try to perform any kind of problematic actions, okay, on your web server. Okay, so even if is logged in is true, because anybody can be logged in on the web server. It's enough to have an account. Like I guess almost all of us are logged in on Gmail, right? So, I mean, of course, I have Gmail, you have Gmail, another one has Gmail, and so on. But Gmail, make sure that when you ask for deleting a certain email with a certain ID, 1, 2, 3, 4, and so on, it's your email and not your friend's email and so on, or whatever email, because you just throw in a random number, okay? And it corresponds to something. Okay, good. Logout, very easy. Logout, I mean, it just destroys the session on the server, okay? The server will clear the session. Really, really trivial with passport. And I mean, yeah, you still have the issue of the cookie on the client. I mean, at the moment, I must admit, I don't remember if it sends something like a set cookie with the expiration date in the past, so then the browser deletes it or not. But I mean, we don't really care because, I mean, this session ID, even if it's sent to the server again, it will not be recognized as an active session, so it has no effect, okay? So it's enough to destroy the session on the server side to destroy, I mean, the session. So it's enough to remove the session ID from the list of the valid session IDs in the memory of the server to destroy the session, because then next request will not recognize you as a valid authenticated user, okay? And you get it just with the logout function, which is added again by passport. And then I mean, you can answer whatever you want back to the user here, just end. It means basically it says nothing. I mean, you could, I think by default it says 200 if you don't put a status, so that's enough. I mean, we don't have really nothing to say, okay? Logout was successful. Yeah, you can say it, but I mean, if it's not successful, actually, I'm not sure what I could do, okay? I mean, logout should work. I mean, if it's not successful, it means you sent a request and you didn't have an active session. Yeah, so, I mean, the result is the same. The session is not active anymore in any case. Okay, so last few things and then we will code a little bit, okay? Yes, oh, there is a question, good. Yes?
Here we are
server side, yes.
Client side, should we also clear the cookie?
I mean, it's true. I was saying, I mean, the cookie is always sent by the browser towards the server. That's true. But I mean, it's a cookie, so it means it's a session ID for an expired session, so it's not useful anymore. So I was saying, I don't remember. I will check when we perform the example what happens, because I cannot tell you at the moment what's happening. I don't remember. But I mean, removing cookies from the client can be done either automatically because they expire, but we say that, I mean, we have no expiration date when we set the cookie at the beginning here with this passport system and sessioning memory and so on. Or because you set another cookie with the same name, so basically you delete the previous one, you overwrite the previous one, or you set a cookie with an expiration date in the past. Okay, and that's the third option. Okay, so basically the browser says, well, it's already expired, so I delete it. Okay. I mean, the fact that you still have this ID on the client side, I mean, yeah, might not be so clean in terms of theory, but in practice has no effect because, I mean, it's an ID for something that basically doesn't exist anymore. So you send it, I mean, you don't really, I mean, it's not useful for you, okay? And your application should be notified of this fact, but you have a React application, you have a state, you can destroy the state of the user. Once you get the answer from the logout, you remove the user object from the client side, and so you know that, I mean, you shouldn't send a request that require to be authenticated to the server, okay? So it's true that at the lower level, since you cannot act on the cookie, you cannot destroy the cookie, maybe the cookie is sent again, but I mean, you're sending it to requests, to APIs that don't need the session ID or the cookie. I mean, it doesn't matter. It's just an additional piece of information. Okay? I hope I answered your questions. And we will see what happens in the example because I don't remember, honestly. Okay? But I mean, it's not a big deal. Okay, any other questions? Otherwise, we finish the discussion just because I don't want you to leave this course thinking that we only have IDs in cookies and sessions are just made of cookies and so on, okay? Because, I mean, we said in the beginning, there is authentication with the credentials, username and password, and authorization. Authorization is a big topic and also something a little bit different from authentication. So it gives you the permission to do something, okay? So, so the point is, authentication recognizes you as a user. It says, I'm a user with ID 1234 with a certain email and so on. Authentication is about what you can do, okay? And to handle authorization after authentication, you have two ways, okay? You can have stateful server, that is what we described until now, or stateless server, okay? And I want to discuss briefly this topic. We are not going to implement anything about this, but I think it's important for the rest of your course of study, okay? So what we saw until now is a stateful server, okay? So the server remembers the valid session ID and the associated user info after the login. That's what we said. And since it stays on the server, this information cannot be maliciously altered, right? Because the trusted version is only in the server. And that's why I discussed so much. You should do the checks on the server side and use only rec user and so on. Because that's the only place we have where the trusted information stays, okay? And each time a request arrives for a restricted resource, so you need to perform some access control, so some authorization check. The server needs to retrieve the info associated with the session and decide if the associated user is authorized or not to perform the action that is requested. Okay? And this works best with a single server that manages everything, and that's fine. Okay? So you see, here there are two servers, but this is time. Okay? There are two servers. I mean, first time, actually, it's the same server. The first time it creates the session ID, stores the session ID with the user information. And then a second time, it gets another request, which is not a login request. it gets the session ID from the client, and it gets the user info, and decides if the request can be satisfied, and sends back the response. Okay? And you see that the client has to keep this session ID information on the client itself, and for us it was the cookie, right? Okay. Okay, that's good, and it works best with a single server that manages everything, because, I mean, the server has to manage the session ID, has to retrieve the user information that is associated with the session ID, okay? But nowadays, things are becoming more and more complex, okay? You have many servers, or you want to be scalable, so have many servers because just, you know, to handle the load coming from millions, billions of users and so on. Or maybe you want to authenticate once and then access resources on different servers and so on. So these are much more complex scenarios. And it is possible to implement a mechanism that allows you to say, I'm authorized to do something, and the server actually trusts you without establishing a session, okay? So, some trusted entity, okay, at a certain point, where I need to start from a place where things are trusted, so like an authentication server, that's fine. It signs a payload, okay, which contains information about what can be accessed and how, the user info if it's needed, when the authorization expires, and so on. And this payload, which we will call token because it's typically called token in this context, is taken and stored by the client, okay? And each time you want to make a request that involves the resource for which you have this payload assigned, stored on the client, you need to send a request plus the signed payload, okay? So this token. And the receiving server just verifies the signature of the token, and there's no need to check if the user established a session with another server and so on, because the two servers are somehow trusted, okay? So server with trusted entity means that it's trusted by all the other servers that will receive the signed token, okay? So in short, it can verify that the signature is valid, okay? Because they have a shared secret, because there is a public and private key mechanism and so on, okay? And in this case, the server, any server, seeing that the signed token recognizes who signed the token, can allow the operation, for instance, accessing information or performing any kind of information, any kind of operation, sorry. Okay? And this is more and more common nowadays. Like you authenticate with Google and then you perform operation on another server, right? What does Google do? It gives you a signed token to be kept on the client side, and the other server trusts the signature from Google on this token, and it performs actions. And this token will say, I'm Enrico, ID 1, 2, 3, 4, and 5, I can do this kind of operations, and so on. Okay? The protocol is a bit more complex when you want more flexibility, but the principle is this one. So you authenticate with a trusted entity, a payload is signed, it says, I am the user X and it can do this and that. And then just looking at the signature, okay, recognizing the signature, the server trusts you because you come with this payload that says what you can do, okay? That's more or less the same mechanism that you have with the identity card, but that's not a good example because it's more about, identity, right? It's like when you have a certificate from the from the university about what you achieved in terms of marks for your exams. Okay, that is the signed payload. You can go to any place, any companies, and say, okay, I got this average score on the courses at the Politecnico and so on. Okay, that's a signed piece of paper quite a number of years ago was, physically signed. Nowadays, it's sort of digitally signed. I think certificates have this QR code, and you can go and check basically on the Politecnico server that you trust as human server, that actually what is written there corresponds to the truth. Okay? That's more or less the principle. And it works also with actual web servers as well. Okay? But we are not going to see this, structure because it's a bit more, how to say, complex for our purposes. We wanted to understand how web application works, security works, and so on. And there are, by the way, other courses that talk about these procedures. Okay? When you talk about OAuth and this kind of authentication mechanism, they work with this mechanism. Okay? Actually, I think not last year, maybe the year before, no, maybe it was last year. I mean, we tried to show something, about the tokens. So if you are curious, you just go back on the GitHub and you put 2025 or 2024, I don't know, I think 2025. And, but the point was, it was very, complex and artificial to test at the exam. So we dropped it, and by the way, it should be addressed by other courses in your course of study. Okay? So the nice thing about the stateless server, so this payload, okay, that you can present to the server is that it scales a lot, okay, regardless of the server. Server 1, server 2, server n, okay? Just need to be able to verify the signature. Okay, like your certificate with the list of exams and the mark, of course, you can present it to anybody. As long as this anybody can perform the check if the certificate is authentic or not, that's fine. Okay, so it automatically scales. There's no need to know the session ID, your authenticate, your credentials, and so on. Okay. And you have no need, by the way, to maintain a list of users, password, hashes, and all this stuff. Okay? Okay, good. So actually, there exists quite a number of standards for implementing these tokens. Okay? These payloads that needs to be signed that we call tokens. For instance, I think last year we were seeing this JWT, JSON Web Token, is also an RFC. But this is very simple format. You have a payload and you have a signature. And there are complex authorization flows for the examples I told you, like you want to authenticate with Google, with Meta, with GitHub, and so on, and do actions on other websites and so on. And this involves more complex protocols. Okay, these are the three ones that are the most common ones. Okay, I think nowadays the Politecnico is using one of them. I cannot tell you. Once it was SAML, but I'm not sure if they changed it recently. Because you can authenticate once, and then you have access to all the resources which are located on different web servers, even though it's always the Politecnico network. Okay, but there are different web servers. You don't have to log in again. Okay, that was not the case a few years ago. Quite a few years ago. Okay, so these are the names, OAuth, SAML, OpenID, and so on. Maybe there can be more or less, and they can, new ones can come out and so on. So you need to stay updated as in any other topics in computer science, in computer engineering, but that's normal, right, for our work. And the important thing is that you know that, session IDs are fine to understand the basic concept, but, you need to be able to authenticate on the same server that then performs the checks, the authorization checks, okay? But more complex situations may exist. Unfortunately, I would say, for the purpose of this discussion, not in general, but tokens can also be used for identification purposes, okay? I can give you a token instead of a session ID. After authentication, you could use it for, to say that you are a certain user and so on. And more or less, it works like the session ID, but what's the difference? The difference is that once you have a token, it expires when there is an expiration date in the token itself. you cannot make it expire before unless you keep a list of tokens which are not valid anymore, even if they are not yet expired. If you keep a list like this, there's no difference with the session ID, right? Because you need to keep the list on the server. If you don't keep this list, I mean, you cannot log out anybody who has the token who has not expired, okay? And that's a problem with tokens and authentication, okay? So we typically don't want to use it for authentication because we want to have a session ID which is kept on the server, and so we can make it expire whenever it's needed, okay? Okay, so in our course, for the purpose of our course is, I mean, we just want you to perform the basic initial authentication, username and password, the classic credential. You establish the session ID. We have the code, and we will see the code today, express session and so on. And then every authorization must be checked on the server in every API through JavaScript code. JavaScript because we are using JavaScript on the server. Okay, you can use any language, but I mean, you need to perform this check. Relying only on trusted information. It means the logged in user taken from rec user plus information coming from a trusted source, means from the database. Okay? Again, this is carefully checked at the exam. I know it could be quite annoying, but make sure you did these checks. I mean, it's really important. I mean, we are here not to really learn, you know, a few functions of React and so on. I mean, of course, I mean, we need a React because it simplifies development on the client and so on, but we need to understand that most of the issues in web application happen on the server side, okay? So that's why we do a lot of checks, and actually, we don't want to use a framework on the server side, so we ask you to perform the checks manually, so you remember and you think about what you are doing on the server, okay? I hope I've been clear enough, okay? So let's have a look at the code, I mean, very briefly, and then we will have a break. But I want to set up the stuff before the break, okay? So you can already have a look at the server in case you don't know what to do during the break, right? I mean, week 11, okay? We have this React QA login, and then after this lecture, we will have one with the 2FA, second factor authentication, but that's for Thursday. So again, there is a client and server folder, and that's just for me for copying for the solution. Okay, so we React QA login client npm. I don't remember if I installed stuff. Yes, not modules. So npm run dev. And let me make sure we are in the same folder. Yes, server node mon index. Okay, so let's just try. I mean, this application is more or less what we see, what we have seen last week, okay? So there's no login at the moment, okay? Maybe there's the route. No, not yet, okay? We still have to implement the route, /login, okay? A page with username and password and a button, login. Okay, good. I mean, not good, but I mean, that's just the application that we had last week, right? But since the backend now checks for the authentication, it doesn't allow me to add anything, okay? And so I told you, the backend has already been implemented. So let's have a look at the backend. So it means the server. Is this one, right? Index, MJS. So let's start from the beginning. Express as usual and so on. Okay, course. We will need to add the credentials include here later. And then API question ID and so on. Let's go to something that is more interesting like the post. Okay? No, that's wrong. I guess put yes. No, this week 3, week 10. Sorry. I'm so messing up. Okay, that's a good one, right? Credentials true. I thought I did, and indeed I did it. Okay. And then you see passport, okay? Passport, local strategy, and so on. That's basically what we saw on the slides, copy-pasting. And you can copy-paste from this code. I mean, nothing to invent here. The less you invent in security, the better. Serialize, deserialize user. Actually, we decided to keep only the ID, okay, in the session, user ID. And so you need to retrieve all the information about the user every time you receive the session ID, at least for this implementation, okay? So we only serialize the user ID. That means that we store it in this, together with the session ID, but when we get back the ID, we need to go to the database and read the rest of the content of the user from the database, okay? Just to give you an idea, what we read is, yeah, I wanted to go to the definition. Why it doesn't move it? Ah, no, implementation. Okay, so select from user where ID is the one that is being given, and we read the row ID, username, and name. Okay, that's what is. We think it's good to have in the rec user element. Okay, for later. Then is logged in middleware, very simple, copy pasted from the slides. App use session, okay, again copy pasted from the slide. Change the secret if you like. I mean this is just something specific of expert session, but I mean it's a way that it uses to generate the session ID, okay, random session IDs. Passport initialize and so on and so on. Let's go to what I was searching before, the post. Okay, post, you see the difference, is logged in. So before doing any action, you go and check if there is a user which has an authenticated session. Otherwise, it doesn't make sense to go on, because we want only to allow authenticated users to add the new answers. Okay, that's what we wanted to do in the application. And then, so if we pass the is logged in test, okay, of course there are all the checks that were already there. I removed the respondent, okay? The respondent is not needed anymore. The respondent is the authenticated user. If I see respondent here, it doesn't make sense. I don't want to see it here, okay? Nor in the exchange between client and the server, that's the stuff I'm looking at the exam. And then, okay, you can do validation, etc., etc. And then you see respondent ID, it comes from rec user. It shouldn't come from the client. It shouldn't be rec.body.something. It's wrong, because anybody can send anything. Any authenticated user actually can send anything here. Okay? It was rec body respondent. Why? Because we didn't have users authentication and so on. So we wanted to have an owner of the response, okay, of the answer actually. And implicitly we also say anybody can say his name is anything and he can add an answer. Okay, that was it is actually the current status of the application, but we want to move to a situation where critical operation like adding, updating and deleting can be performed only by authenticated users, and editing and deleting can be performed only on the answer owned by the user. Okay, so there is an additional check. So addition, you only need to be authenticated and then you are recognized through the session. But like editing, okay, editing, of course, is logged in. Respondent, again, is not needed. I cannot change the respondent name. It's me. I can just delete the response and the answer, actually. Okay? And so there is a check. Update answer with the rec user ID. Let's have a look here. Implementation. Update set where ID and respondent ID equal to, okay? If the two conditions of the where are not matched, the update doesn't happen, okay? So you can do the checks at any level you like. You can do it in JavaScript, you can do in SQL like here. Here it's typically quite simple, right? Because the database has the owner and you can simply put it into a where clause, so it's easy to check. If it fails, you simply say that I cannot update, that's all, okay? Or I think there is the vote, anybody can vote, so we didn't ask for the authentication. The delete, again, delete rec parse, rec user ID. You cannot have rec body ID, rec params ID, everything else is wrong, okay? ID needs to come from rec user, ID needs to come from the server side. Implementation, again, same technique. Okay? Or you can have a check in JavaScript. In the slide, I did a check in JavaScript. Why? Because it's more convenient, right, for explanation purposes. Okay? So that's a server. And you can try, you can even run the REST client, try to send a node, and it will fail because you didn't set a cookie. Okay? If you take a valid cookie and so on, you need to work a little bit. And maybe the REST client even remembers cookie because it's, you know, quite advanced, the software. But I mean, the point is that if you didn't authenticate, actually you cannot perform some action corresponding to same APIs on the server. Okay? Okay, so you have, I mean, this code is already online as usual. So you can have a look at the code. And I think I can stop here for the moment. And in the following 1 hour and a half, we can do the rest of the implementation, mostly client side, reasoning about what makes sense, what it doesn't make sense, and you know, how to handle these authentication issues, the form, etc., etc. Okay? If you have any questions or comments, I'm glad to answer. Otherwise, I think we can break it for 10 minutes, maybe not too much more than 10 minutes, not okay, and then we can perform, I mean, go on with the implementation, okay? Okay, no questions, so thank you.